All right, all right. Let's talk about rational equations. So first, I want to do an example here. Rational equations we've done before. But the only difference between what we've done so far and what we're about to do is the fact that the ones that we're about to do has x or variables in the denominator. And we got to be careful because if the denominator is 0, then the fraction is undefined. So we got to be careful with the answers that we get. So we also now have to look at the restrictions and not just, and we're also going to have to like learn how to reduce. If it's just variables, we're going to have to be able to factor, we're going to have to be able to distribute, we're going to have to do a whole lot of things and bring back some of the stuff that we've already known and bring it back and kind of be relearned. All right, so let's start with something that I kind of want to bring up just so that we can kind of see an example of this. So we'll call this example 1. So the first example I want to start with is this. If I have x plus 4 over x plus 1, that's equal to 3 over x plus 1. So if I look at this, what I can see is that the two denominators, that one here and that one here, are both the same. So with that being said, I can write an equation that says x plus 4 is equal to 3. Okay. Since it's only because the denominator is exactly the same, so I can write that equation right there. Okay. So, so that way you know that. And then one of the things we'll find out from here is that x is equal to -1. All right. So typically we would box that answer and we're like, yeah, there's my answer, right? However, we can't box that answer. Because if we look back at the denominators being the same, we can see that if we put x in, or -1 in for x, then my denominators will be 0, right? And my denominator is 0, then my fraction is undefined, so therefore this problem is no good. So therefore I am taking that out. All right, and let's take these out so that you guys can start seeing the rest of the problem here and those. All right, so my answer is going to be, we're going to have to reject this first of all, right? So that's number 1. So we're going to reject it since x equals to -1 would make the denominator equal to 0. Therefore, the fractions would be undefined. Okay? So at least we know that. So with that being said, my solution is no solution. There we go. All right. So we need to understand that. So we've been doing a lot of restrictions in 6.1, 6.2, 6.3, and then we start asking less and less and less and less about restrictions. Where in 6.5 and 6.6, we're not even going to bring up restrictions. We're going to let you solve and everything else, and it's going to be your responsibility to kind of check your answers, to check yourself to see if it would make any of the denominators 0. So if it does not, then you can't accept the answer. If it does, then you have to reject the answer, and you can't use that answer. Now, if I got 2 answers here and I got them both, and either answer I use would get a denominator 0, then I can't have either answers, right? Then again, it'll be no solution. But if I got 2 answers and only one of them gets canceled out, then that means I can use the other as my solution because I'm rejecting one and keeping the other. All right, so let's try a couple more examples and let's see where those go. And what I'm going to do is put the steps down on side of it as well so that you can see what kind of stuff I do as I'm going through a problem step by step with the problems, and look at the color code. So here we go. Example 2. All right, example 2 is 2 over x minus 3 minus 4 over x minus 4 is equal to negative 3 over x squared minus 7x plus 12. Okay? So, what's rule number 1? Oop, that's pink. Rule number 1 is this. Rule number 1 is to put parentheses around each binomial. Okay? So we see binomials, we're going to put parentheses around it. All right? Ooh, so hard to do. Excuse me. All right? So what's step 2? Let's call this green. All right? So step 2 says factor the bottoms. Bottom or bottoms. All right? So we look at this first fraction, there's nothing to factor. Second one, nothing to factor. However, the third one, the bottom is a trinomial, no GCF. Go through the AC method and you're going to get x minus 3 and x minus 4. All right? So that is step 2, except I did it poorly because I didn't color code it for you. There we go. Now it's color coded for you. All right? So that's factoring the bottoms. All right? And what these do next? Yeah. So our next step is going to be, so step 3 is to get each fraction, each fraction whoa, what's going on, to have the same denominator. Okay, so first let me rewrite all of this here out and then we'll talk about that. So over here I have 2 over x minus 3 minus 4 over x minus 4, and that is going to equal to negative 3 over x minus 3, x minus 4. Okay? So what do I mean by step 3 here? So what I mean by step 3 is I would typically ask myself the question, stand here as this sister right here, and saying, what do they have that I don't have? All right, so clearly what they have that I don't have is the x minus 4. So if we do it to the bottom, you have to do it to the top. Okay? Then I would be this sister here and saying, what do they have that I don't have? And it's very clear that they have an x minus 3 that I don't have. Okay? And if I was this sister here, I can ask, what do they have that I don't have? And the answer is, you have everything. So that part is good. Okay? So now, if you look at each fraction, it has the same denominator, right? Look at this right here. That denominator is the same as that denominator, which is the same as that denominator. Each of them has an x minus 3, and each of them has an x minus 4. All All right. So, that being said, let's get to step 4. Step 4 is write the equation. Okay? Meaning, what we're going to do is, since all the bottoms are the same, we're going to write the top to be the same. So it's going to be 2 times x minus 4 minus 4 times x minus 3, and that's equal to negative 3. Okay? That's pretty simple. And then step 5 is to solve. Okay? To solve, got a couple of things to think about. Part A, you may have to, you first combine like terms. Right? With that being said, you may need to distribute. Okay? And B, if you see an x squared think I'll write down the name here. Quadratic equation, which you know it as ax squared plus bx plus c equals 0. Okay? So there's my 5th step there. All right, so let's go ahead and solve now. So first part of it is combine like terms. Okay? So I got 2x minus 8 minus 4x plus 12 is equal to negative 3. And what I have is the x terms are the same here, and the non-x term is the same here. So what I have is negative 2x plus 4 is equal to negative 3. Negative 2x is equal to negative 7. So x is equal to 7 halves. So the question is, can I have x equal 7 halves? So we come back up here to where the denominators were existing. If we look at the denominators, the only thing we know is that x cannot be 3 and x cannot be 4. Okay? So those are only 2 numbers that can't be. All the rest of the numbers will be all reals except for those 2 numbers, and this is amongst all reals and not the same as the denominator. So therefore, that's why we can cancel. All right? So that's the first example we have. All right? So let's take a look at another example here. Example 3, I believe we're at. Trying to figure out which one I want to do. Ooh, yeah, let's do that. So I'm going to do this one. 12 over 9 minus a squared plus 3 over 3 plus a is equal to 2 over 3 minus a. Okay? So with that being said, the first step is what? Step 1, parentheses around each binomial. Okay? So parentheses, parentheses, parentheses. Okay? So what's step 2? Step 2 was in green. So step 2 says factor the bottoms. Okay? So factor the bottom. So again, I have 12 over, ooh, that's a difference of 2 squares. 3 times 3 equals 9. A times A equals A squared. 3 plus A. Okay? And then plus the rest. Plus 3 over 3 plus A. And is equal to 2 over 3 minus A. Let's try that again. Okay? So there we go. So step 2 is now done. So what's step 3? Get each fraction to have the same denominator. Okay? All right, so first I got to rewrite these a little bit. So I got 12 over 3 minus A. 3 plus A plus 3 over 3 plus A is equal to 2 over 3 minus A. Okay? So I'll ask myself, while I'm standing here, no, not that one, this one. I'm going to stand right here and saying, what do they have that I don't have? And you're like, I got everything. I got one of each. I'm good, right? So then if I bring this over here, boom, and say, what do they have that I don't have? Well, both of them have a 3 minus A that you don't have. But you already have a 3 plus A that they have, right? All right. So now again, the same thing. What do they have that I don't have? Well, that would be a 3 plus A. And if you do it to the bottom, you got to do it to the top. Right? All right. See here. With that being said, now again, look at your denominators. Does 3 minus A, 3 plus A, is there a 3 minus A, 3 plus A there? Yep. Is there a 3 minus A and 3 plus A there? Yep. So therefore, the bottom's all the same. Okay? So, step 4 is going to be write the equation. Not sure what I was trying to write. Awesome. All right, so let's write the equation. The denominator is all the same. So it's going to be 12 plus 3 times 3 minus A is equal to 2 times 3 plus A. There's my equation, right? And then step 5 was to solve. So under solve, there was an A part and a B part, right? The A part was to combine like terms. Okay? And part B is that if it's x squared, you will how should I say it? If you see x squared, then you should get everything to one side, like ax squared plus bx plus c equals 0. Okay, so you'll have quadratic equation if you see an x squared. Okay, so if we look at this, what do we get here? We get 12 plus 3. Oh, that's not 3. 3 times 3 is 9 minus 3a is equal to 6 plus 2a. Okay, so combine like terms. Over here I got those two, and that's it. So we get what? 21. So we got 21 minus 3a is equal to 6 plus 2a. Okay, I'm going to add the 3a over to the right. That means I got to subtract the 6 over. So I'm going to have 15 is equal to 5a. So a is equal to 3. So my question to you is, it looks simple enough, but can that be my answer? And the answer is no. So first thing we're going to do is get rid of that box, because that box doesn't belong there. So I'm going to make this arrow right here. Restriction is that a cannot equal to b. I'm sorry, 3. Okay. So therefore, my answer is going to be no solution. All right. All right, let's do another one. Oopsies. Oopsies. There we go. So we're at example 4. Get that right. Yeah. Okay. Our last example. Here we go. Need a power up for my last example here. We got 64 over x squared minus 16 plus 1 is equal to 2x over x minus 4. Okay? Step 1, parentheses around each binomials. Okay? So we're going to go beep, 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 beep. Done. All right? What's step 2? What's step 2? You're right, you're right. Factor bottoms. So, okay. Over here I get 64 over, difference of 2 squares. X minus 4, x plus 4. Plus, I'm going to put this as a fraction. 1 over 1 is equal to 2x over x minus 4. Whoa, a couple of things I got to erase here. That doesn't belong there. It's 1 over 1. Okay, so I've done factoring the bottom. Step 3. Get each fraction to have the same denominator. Okay. Okie dokie, let me rewrite this. So I have 64 over x minus 4, x plus 4, plus 1 over 1 is equal to 2x over x minus 4. Okay? So, I asked myself, what does she have that I don't have? What does she have that I don't have? Well, this one doesn't have x minus 4, nor does it have x plus 4. So, what we do it to the bottom, we got to do it to the top. And this one here has an x plus, needs an x plus 4. Okay? So let's look at the denominator again. Are these the same? Do they all have x minus 4 and x plus 4? Yeah. All right. And step 4. Write the equation. So since the bottom's the same, the top's going to be the same. So I got 6 plus 1 times x minus 4 times x plus 4. Why did I write 5? I don't know. Equals 2x times x plus 4. All right. And step 5. Solve. Okay, so let's solve. So I have 6 plus x squared. I would just write the whole thing out. Plus 4x minus 4x minus 16 is equal to 2x squared plus 8x. Okay, there we go. Now, I want you guys to notice something, though. Notice something. See the x squared? See the x squared? See the equal sign? That's when I know, hey, look, there's an x squared, so therefore I'm going to get everything to one side and factor the non-zero side, okay? It doesn't matter if you bring it all to the left or all to the right, okay? So in this case, I'm going to bring everything to the right because if you when I look at the x squared, if I bring it to the right, it will stay positive, but if I bring it to the left, it would be negative. So I'm going to keep it there. All right, but let me first combine like terms. So I'm going to have, let's look at the like terms. I got that one, nothing over here. Let's pick another color, like bleu. These two are the same. And then these two are the same. Okay? So let's see what I got here. I'm going to have x squared. Negative 4 positive 4x goes away. And then I'm going to have minus 10 is equal to 2x squared plus 8x. Awesome. Now I'm going to bring everything to the right side. So I'm going to have 0 is equal to x squared, 2x squared minus x squared is going to be x squared plus 8x. And then when I bring the 10 over, it's going to be plus 10. So I got to add 10 to both sides. So I got to find two numbers, multiply together to give you 10, but add together to give you 8. Oh, no. X squared. Oh, shoot. That's where I went wrong. Sorry, guys. These are 4s. 64. 64. Yeah, I copied it wrong. I apologize. No wonder why. I was like scratching my head going, something's wrong. But this is not negative 10. So what this is 64 minus 16. 48. This is going to be plus 48. So this will be minus 48. And let me think here. Let's take a look. Negative 48. Negative 148. Negative 224, negative 316, negative 412. There it is. All right. So what I'm going to do is have 0 equals x squared minus 4x plus 12x minus 48. Okay. Now I'm going to split it down the middle. 0 is equal to, let me see here, it'll be x, leaving you with x minus 4 plus and 12, leaving with x minus 4. Okay. So that means I got x minus 4 and x plus 4. Wow. Let's try it again. How about x plus 12? Woo! Is equal to 0. Alright? So that means I have x equals 4 and x equals negative 12. Alright? So, question is, can I use both of these? So let's look back up here on the original. And the answer is, what can I not use? So when we look at these denominators here, let's just take this one right there. Okay? If I was to look at that denominator right there, what would be my restriction? X cannot equal to 4, and x cannot equal to negative 4. That's correct. Okay? So with that being said, ooh, crap, I got a x equals 4 here. So this one right here is going to get rejected. Right? But this one here is going to be my answer. Everybody see that? So I got two answers, but one of them is going to get rejected, so therefore the other one is the answer. Now, if the other number was, let's say, negative 4, then we would have rejected both of them. So let's go through this problem again. So what did I do? I put parentheses on the bottom or around binomials, and then from there I factored the bottom, and then from there we ask, what does she have that I don't have, or what did they have that I don't have? And then you write your equation since all the bottoms are the same. And then you solve, you simplify by combining like terms. And once you do that, you're going to see x squared. And when you see x squared, you're, ooh, quadratic. So you're going to bring everything to one side. And from there, you factor the non-zero side and set equal to 0. All right? Hope you enjoyed it.